This is Trial Exam 2019, ST&SP paper question number 3. So now we've got a student investigating refraction of light by using a salt solution in a hollow prism. They shine a ray of blue light from A to B and traces the path of the ray through the prism. The diagram shows the path of the ray of the blue light. Explain what is meant by the term refraction. So it's just explained, but it is 1 mark. So you can just say here something like it's a change of direction of a wave. And if you want to go into a bit more detail, you can say from one medium to another. Very unusual you'd see explain question being 1, but it isn't. It is a slight explanation that it is a change in direction, but we're not using the word because, so we didn't have to go into too much detail there. On the diagram, show the normal line at B and measure the angle of incidence. So you should have used a protractor to show that you were measuring this angle here as being 90 degrees to where the ray struck the surface. So once you had that on, you were looking for this angle between the ray and the normal, and you should have got a range between 31 to 34 degrees. So you're going to get marks there by a right angle, the correct incident angle used, and then the measurement somewhere between 31 and 34 degrees. Okay, so now they shine an array of red light in, and it's still along A to B. The refractive index of the salt solution is lower for red light than it is for blue because it's of a different wavelength. On the diagram, we're going to sketch a possible path for the red light through the solution. So you get 3 marks again here, and you're going to get 1 mark for showing that the angle of refraction for red is greater than the angle of refraction for blue. So here, again, this is between the ray and the normal. The one for red is bigger than the one for blue. So that would be correct, because red light refracts more than blue. Then you're going to get another one for showing that it's still within this area. Notice I've drawn this line on, doing it without a ruler. I think a lot of people would do it here and then down. It should still, it won't go above its own ray or own incident ray, so it should still be within this area. Don't draw it too high, or it shouldn't be below the blue light either. Then we're going to say that the other one is when it comes out, that it's not going to just go out and go like that. They should still be diverging when they come out, but still angled downwards. And there should be less refraction for blue on emergence than there would be for red. So they should still be getting further apart, but they still should be angled downwards. So tough one. Check your diagrams with your teacher if you're not quite sure. Suggest what would happen to the path of the blue light if the student used a salt solution of higher refractive index. So we're looking for 2 marks here. We're just suggesting what happened. So if it's a higher refractive index, blue would refract more. That's pretty obvious, straightforward for 1. So 2, you could say it would go nearer the normal line. Spelled nearer, right? Nearer the normal line because it's refracting more. Or you could say R will be smaller. Okay, any of those for the first mark. So any of those would get you the 1 mark. For the second, on emergence, it will bend more. Or it will deviate by a larger angle. Deviate a larger angle. Okay, so this is a higher refractive index now. So when it goes into the material, it's going to bend more, so we would expect it to come down here, closer to that normal line. And then when it pops out, it's got a greater angle to go through when it comes out. So it's going to deviate larger than previously, still using that normal line. So it's probably going to come out down here. Again, if you want to check with your teacher on your diagram. Now we go into the graph. So I've had to draw it previously, so it wouldn't take so long. So we've got these to plot. As always with a graph, you're going to get a mark for the axis with the labels. So you've got the labels, and it's got to have the units with it. You're going to have scales. Now you're going to get 2 points you're going to get one of those taken away for each correct point to a maximum of 2. So you should have had all of them on this curved line, and you should have a curve as well for 5 marks. So if this one was up here, say, I'd drawn it in the wrong spot, I would lose one of those. Oh. Scales, yeah. Yep, and then one of those again, I would lose another one, so I've got to make sure they're all on the correct line, and that would give me the 5 marks. It should look like this for the 5 marks. Good scales drawn, everything labeled, and we've got a line of best fit through those correctly plotted points. Once we've got that, we're going to circle the anomalous reading, which is quite easy because it's the only one that's not on our curved line. But then it says, circle the anomalous reading and suggest what the correct refractometer reading should be. So we've got to circle that point and say it should be around 50 for that one. So we've circled it, and we've got the correct refractometer reading for that one. Use your graph to find the sugar concentration when the first refractometer reading is 80. So you should read it from your graph, but it should be around 63. We will accept a range between 62 and 66. Describe the pattern shown by your graph. Looking for 2 marks here because it's just a describe. Anything that would mention the shape, pattern, sentence, something about positive correlation. It's a positive slope, so it keeps going bigger. The gradient changes. The gradient is changing all the time. It's non-linear. It doesn't go through the origin. There's a lot to talk about with this graph. So we were just looking for 2 good sentences that made sense about the graph. You could have had an attempted mathematical description, something about it being exponential or similar to that. You could say the refractometer readings increase faster than the percentage of sugar concentration, which is why the gradient is changing. Anything like that, would you got you the marks? That was a long question, sorry about that. That was question number 3.